us begin our class, second lecture. Can you hear my voice, all of you?
Yes, ma'am.
Okay. So we were discussing last class. I think I'll recap slightly and then we move forward. If you have any doubt, just let me know. I'll be asking questions if I feel so in between. Okay. So we were discussing about support conditions. And it is very important for before analyzing any structure, because this is a subject which is a structural analysis. Okay, and this is theory of structure. So before analyzing any structure, we should know everything about how the structures are supported and how many forces that can occur at the support. So quickly I will recap. I think all of you have understood well. If I'm not wrong, this is a fixed support. There are other type of support. There are roller support, okay, and other kind of support are hinge support. These three are the main, of course. And of course the free, I mean, if the cantilever beam is there, you know that there is a free end. Okay, so what are the conditions of? There are four parameters which I was talking about. That one is moment, other one is shear force, rotation and displacement, that is delta. Okay, and you should be able to write four parameters, that is moment, shear, rotation and the displacement. Okay, so moment we are calling m, v we are calling shear force, then theta we are calling rotation. At that particular point, rotation matlab at this point, what is the rotation, right? Something like that. Then delta. So first case, when you have fixed support will deflect slightly away from, because it's we have already tying up so much, so there is no scope of displacement and rotation. So this is equal to 0 in the fixed end. Both quantities are 0. Because if you see rotation मानी slope, आपका ये beam है, अगर ये rotate हो रहा है, it deflects, then it can rotate also, and this is your rotation. So any beam, if it deflects, if it is a cantilever beam, if it is deflecting, along with deflection, there is also a slope. Rate of change of displacement is changing, dy by dx is equal to theta. That is called rotation in the beam. Okay, so this you have to understand that if this is a cantilever beam and this is deflecting like this, then because the slope is changing, right? So I have to calculate, okay, what is the slope here, what is the slope here? That is the angle of rotation, that is dy by dx. Okay, and then we will try to see how to figure out this quantity later on in the analysis part. But this is your basic thing. I will also repeat this in some when we discuss about beam theory and all. Now, since theta and delta deflection, because fixed end, it is so fixed that there is no displacement happens, and rotation also does not happen, because if beam wants to deflect, it will deflect slightly away from the loading. For example, if I am talking about fixed end beam and then you are loading this beam, then it will be slightly deflecting like this. Whereas if you have roller and the hinge support, simply supported beam, all of you know, this beam will deflect like this. So look at what is the difference in between these two. One is, of course, here there is no deflection and rotation, but here deflection is 0, but there is a rotation. Okay, so you have to observe. From observation you will understand that roller and hinge support, they have rotations. So rotations means theta is not 0. We need to calculate theta. Okay, here, because there is no reactive moment which can resist the rotate to prevent the beam to rotate at the end. Okay, so here in this case theta is not 0. Okay, delta is 0. Vertical deflection is 0. That means now we correlate with the moment and shear force. So wherever, if theta is not 0, there is no moment. अगर moment है तो theta 0 होता है. Okay, so moment is equal to some moment will be there, reactive moment here. There will be vertical force, there will be horizontal force, and one moment, whereas here only just one vertical reaction, here vertical reaction and horizontal reaction. So whenever there is a moment, when you apply moment, fixed moment, I mean reactive moment, theta will be 0. So if theta is 0, there is a moment. This you have to keep in mind. If delta is 0, there is a shear force also. Okay. Now, if it is not 0, then moment is 0. You compare these two. If theta is 0, moment is not 0. But if theta is not 0, moment is 0. Vice versa situation. If delta is 0 here, then there will be shear force. Shear force won't be 0. Okay. तो जो जीरो क्वांटिटी है डेल्टा की वहां पे shear force 0 नहीं होगा क्योंकि वहां पे वर्टिकल रिएक्शन एक है. वही आपका shear force आपने प्लॉटिंग भी किया होगा बेंडिंग मोमेंट shear force डायग्राम. Simply supported का shear force diagram is something like this, right? So you can see here there is a shear force. So there is a reactive force actually. Its magnitude is same. If it is P, then it is P by 2 or something. Okay, so here also there will be P by 2. So that's the reactive force as well as your shear force. If deflection is 0, there will be shear force. It's not 0. Similarly, now if there is a hinge support, moment, shear force, theta and delta. Here at the hinge support, again moment is 0, but shear force is not 0. Okay, delta is 0. I mean displacement, rotation is not 0. Like this. And free support. So free support पे क्या condition है? When I am having free support like this. So what is the condition of moment? There is no moment, there is no shear force, both are 0. And because of that, both rotation and displacement will not be 0. अगर rotation displacement 0 नहीं है, तो moment और shear force 0 ही होगा, because there is no reactive force which can prevent the displacement. This beam will deflect. There is no reaction which can prevent the deflection of the beam. There is no reaction which can prevent reactive moment which can prevent the rotation of the beam. So you can write here moment and shear force are 0, but deflection and rotations are not 0. Okay, so this you have to keep in mind. So everybody understood this? Any questions here? If you still have any questions, please understand. You can ask me now.